Have you ever wondered if you could take an old invention, one that's just locked away in some complex document, and bring it back to life? Not with a whole team of engineers, but with an AI? Well, today we're going to look at a really cool case where that's exactly what happened. So this is the big question, right? Can an artificial intelligence actually read the blueprint for an invention? And we're talking about a super dense technical patent here, and then turn it into a working virtual model. I know, it sounds a little like science fiction, but you're gonna want to see this. Okay, so our test case isn't just some simple gadget. We're looking at an incredibly important piece of tech, a device designed to detect epileptic seizures. We're going to see how an AI took on the massive challenge of understanding and recreating the core logic of this life-saving invention, using nothing but the original patent document. And here it is. This is ground zero. It's not some user-friendly manual, This is a United States patent. It's jam-packed with legalese, technical diagrams, and scientific descriptions. For a human, this is a ton of work to get through. So for an AI, it's a huge challenge to not just read this, but to actually comprehend it. So what's this thing actually supposed to do? Well, at its heart, it's a wearable device, something you'd put on your arm, that uses an accelerometer to measure movement. But here's the really clever bit. It analyzes the signals from that motion, its frequency, its amplitude, to tell the difference between a dangerous seizure and just an everyday activity, like typing. It uses some pretty smart math, like autocorrelation, to find those specific repeating patterns. And if it does, boom, it triggers an alert. Now for the really cool part. How do you go from a flat, static PDF document to a dynamic, working piece of software? This is where the AI comes in. Its entire job is to turn all those pages of text into functional Python code. So let's break down how it pulls this off. The whole process is brilliantly systematic. First, the AI just ingests the entire patent. It reads everything. Then it goes on a kind of treasure hunt, scanning the text to extract the key scientific parameters, the numbers and variables that make the whole thing work. But here's where it gets really intelligent. Patents don't always give you all the information, so the AI has to assume or make educated guesses to fill in the blanks. And finally, with all that information in hand, it generates the code, a complete simulation of the original device. And think about that extraction step for a second. Hidden somewhere in all that dense scientific language, the AI successfully found and pulled out 12 distinct critical parameters. These are the hard numbers that really define the invention's logic. And this is just as impressive. To even make the simulation work, the AI had to figure out 8 additional parameters that were only implied, not explicitly stated. This isn't just data processing. This is a form of computational reasoning. It's filling in the gaps, just like a human engineer would have to. So the AI read the patent, it wrote the code, but the million-dollar question is, does it actually work? Now we head into the digital proving ground, where we get to test this virtual invention and see what it can really do. What's so fascinating here is the sheer range. The AI didn't just model one thing. It built a simulator for all sorts of different movements. It can generate the signal for a high-amplitude clonic seizure, sure, but also for something as subtle as typing on a keyboard. It's basically learned the entire landscape of movement described in the patent. And this shows you exactly what that simulation looks like. Now, let's be clear. This isn't a recording of a real event. This is pure synthetic data. It's a signal waveform for a clonic seizure, created entirely by the AI's Python code, based on its understanding of the patent. It literally translated text into a time series signal. This is the huge leap forward. On the left, you see the kinds of figures from the original patent. They're static, maybe a bit fuzzy, just a single snapshot in time. On the right is the AI's output. Clean, modern, and most importantly, it's dynamic. The AI simulator can generate endless new data for any of these scenarios whenever you want, something that original PDF could never do. And right here, this is the wow moment. This plot is the proof that the AI truly gets it. It has mapped out the different motion types based on their frequency and amplitude. And look, you can clearly see how it separates a clonic seizure from typing on a keyboard or a night stretch. It has recreated the core logic of the invention, the ability to mathematically tell one type of movement from another. So this is more than just a clever party trick. Having an AI that can automatically build a working model from a research paper or patent, well, that has massive implications. So let's zoom out and talk about the bigger picture and why this all really matters. The potential here is just enormous. I mean, imagine being able to speed up research by instantly creating a working model of a paper you just read, or generating huge, perfectly labeled synthetic data sets to train other AIs without needing to collect real-world data. You could rapidly verify the claims made in a patent, or even prototype new ideas faster than ever before. It's a powerful tool for making science more reproducible.
Now, it's really important we're all clear on this point. The data the AI creates is synthetic. That means it's generated by the computer, inspired by the patent. It is not the original data from the inventor's own experiments. Its whole purpose is to illustrate the scientific principles and let us explore the model in a new way.
And of course, we need to be realistic. The people who made this are very clear that this is an early version. The quality of the output will always depend on how good the source document is. You can think of it as an incredibly powerful starting point that researchers can then take, verify, review, and build upon. So we're left with this final thought. We've just seen an AI build a bridge from old knowledge to new possibilities. If we can automate the process of understanding what we've already created, what does that free us all up to invent next? What new frontiers can we explore when the act of reproduction becomes almost instantaneous?